Hi, my name is Carter with First Updates Now. I'm here with Braden, Jonah, and Evan with the RoboDux, currently second OPR in the world. Beautiful robot at the Michigan State Championship. Let's see what is behind the bot in a few moments.
This video on fun is brought to you by viewers like you and also in partnership with the following. Discover how Kettering University students engineer their success with Kettering's amazing co-op employment programs where students earn great pay and gain valuable experience. Those accepted into Kettering University can apply for a robotics scholarship, providing up to an additional $5,000 a year in tuition assistance. Head on over to kettering.edu/first to learn more and apply. Support Fun's content creators when you sign up for a membership on YouTube Join. You'll get access to special perks like emotes, loyalty badges, and Fun members will even get early access to our scheduled videos and more. 100% of this revenue will go back to our correspondents to help recognize their efforts. Click the join button in any YouTube video to pledge your support.
All right, Jonah, can we get a little bit into the pixel manipulation mechanisms on your robot?
So we have a touch it get it system, we call. So we have this rotates to intake the pixels. These flaps right here hook onto the pixel to suck it in. And we have a bottom roller right at the bottom down there to lift the pixel up. So then when we lift it up, it'll be able to suck it right in. Then we have wheels right here to suck up the pixel. So then when we do that, it'll get into this cage right up here. So, and then this cage, switch the cage. In this cage up here, it will suck them in, and then these two fingers will close it and hang it. So then our lift will go up and take those fingers out to drop them 2 pixels.
Awesome. All right, let's get into the lift mechanism a little bit more, your climbing mechanism, and your drone launching mechanism.
So, our lift uses drawer slides, and we have it powered by 3 motors. One of the things we wanted on our robot was our climber to be on our lift so that we can be efficient with this game. So that we put that on there, and then we have their 3 motors to power it really good. Our airplane launcher took a bunch of several design steps, and we eventually ended up with a T-shaped shell with springs to pull back, a latch to hold onto it, and then a servo to release it.
Awesome. Can you guys tell me a little bit about the mechanical iterations that went into this? Because like you were saying, this obviously isn't your first drone launcher. Tell me a little bit about the different aspects, maybe your intake, your outtake, anything like this little finger, different iterations that went into the mechanisms on your robot.
Okay, so what has changed with our robot a lot of times is our airplane launcher. Our airplane launcher used to be on the left side of our robot, now it's on the right side of our robot. We had many designs of it. We added a latch and a roof to it to hold the airplane in, and we added more angle to it, so then it can nosedive down and get to zone 1. We also changed our webcam. Our webcam used to be in the middle right here, and then after that, we moved it to the side, so then we can save half a second during our auto.
All right, and then I see this little mechanism here. Can you tell me what that is for?
This mechanism right here is our alignment device. So we don't want to be off at auto because that can really throw us off. So to have a mechanism that stays on a robot and can measure it, we just fold this down, line it up with the little like waffle grids on the foam tile, and then we flip it back up and we're all set.
Awesome to hear. That's on the mechanical side of this robot. Let's hear a little bit about the software side. Any sensors that you guys use to make this thing work?
On our robot, we have a few sensors, one of them being a touch sensor on the back of the lift. When the lift goes down, it presses the sensor, so we know that the lift is in the home position, so it stops trying to push it down anymore. We also have a distance sensor on the back, so when we go up to the backdrop, it measures the distance and automatically slows down at a certain distance, so we don't slam into it extremely fast. We also use a webcam, so we can take pictures of our team element in autonomous and place it on the correct spike line.
All right, this robot looks awesome, software-wise, mechanically. It makes sense that they're second OPR in the world. I'm really excited to see how this goes this weekend for you guys. So good luck. And this is Carter with First Updates Now, signing off.
This video on fun is brought to you by viewers like you and also in partnership with the following. Discover how Kettering University students engineer their success with Kettering's amazing co-op employment programs where students earn great pay and gain valuable experience. Those accepted into Kettering University can apply for a robotics scholarship, providing up to an additional $5,000 a year in tuition assistance. Head on over to kettering.edu/first to learn more and apply. Don't forget to like, subscribe, and ring the bell to stay up to date on our new videos. Keep the conversation going and provide your input to our content. Most live shows can be found on the First Updates Now YouTube channel, live competitions at twitch.tv/firstupdatesnow, and join our Discord at discord.gg/firstupdatesnow. Check our other social offerings on TikTok, Instagram, Facebook, and Twitter.